Hello, AP Physics 1, this is Mr. Ng, and I thought I'd walk you through number 27 from Chapter 2 in Giancoli. This is the last problem in your current homework set. Let's hop right into it. Here's the problem. A car is traveling 85 kilometers an hour and it strikes a tree. The front end compresses and the driver comes to rest after traveling 0.8 meters, and it wants the average acceleration. It wants acceleration of the driver during the collision, and weirdly it wants it in G's. Thanks a lot. Alright, let's go through our steps. The first step that we want to do is we do that whole VVATX, right? So let's do VVATX. This is V initial, this is V final. V initial is 85 kilometers an hour, and that sucks because this is in a different unit than what the answer should be. The answer is going to be in meters per second, and we got kilometers an hour. So let's very quickly let's give ourselves some space down here to do a conversion. Let's convert 85 kilometers an hour. And let's get out of kilometers. To do that, kilometers on top, let's put kilometers on the bottom. That way the units cancel. And we want it in meters. I know that every 1 kilometer is 1,000 meters. Pretty easy, right? Just simple dimensional analysis. Notice that the units will cancel and our value doesn't really change. 1,000 meters is 1 kilometer. It's basically multiplying something by 1. So nothing changes really, except for the units. So meters is good. But I want to get rid of hours. To get rid of hours, I'm going to write hours on top. Alright, and I could probably go to minutes. 1 hour is 60 minutes, and then let's multiply this and get out of minutes and into seconds. Right, 1 minute is 60 seconds. So hours will cancel, minutes will cancel. I'll end up in meters per second, which is pretty darn good. If I do some math, I get, let's see, boom, 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 boom. I get 23.611 meters per second squared. I'm going to add in those little extra units. That's just a habit of mine. I don't like putting it down to sig figs until the very end. That's just what my professors taught me to do. I will say a lot of the books, they don't do that, and sometimes my answers might be a little bit off. But this is the practice that I've been taught to do in lab, so that's what we're going to do. So that means V initial, we don't need to write 85 kilometers an hour. We're going to write 23.6 meters per second squared. The V final is going to be 0, right? It goes to rest. Look at this thing, at rest. Meters per second. Oh, this is not seconds squared. Acceleration, we don't know. This is what we want to know, so I'll put a question mark there. Time is not mentioned at all, but x is mentioned. Our delta x is 0.80 meters. Okay, on to step 2. We got to pick an equation. So we need an equation without t. There's no t in here. You have a t, get out. You have a t, get out. And we want something with an a, so this is the only one with an a. So we're going to use that equation. V final squared is equal to V initial squared plus 2a delta x. This I write delta x is the same thing as x final minus x initial, right? It's just a change in x. And in our case, that delta x is going to be 0.8, so don't even sweat it. After I chose an equation, number 3, solve with variables. So there's one variable I would do want to substitute in, and it's any zeros. That just makes things a lot easier. It's a good habit to have. So instead of VF, let's put 0 squared. Oh, 0 squared is 0 is equal to the V naught squared plus 2a delta x. Let's just simplify this. That means negative V naught squared is equal to 2a delta x divided by 2 delta x divided by 2 delta x. That means the acceleration is equal to negative v naught squared. FYI, this negative is on the outside, right? We're not gonna, the whole value at the end is gonna be a negative value. Okay, don't let the square cancel out this negative. We want to keep that negative. Divided by 2 times delta x. So we can plug in. When we plug in, this becomes 23.6 meters per second. We're going to square this sucker. It's a negative on the outside. Divided by 2 times 0.8 meters. If you punch in a whole bunch of math, you end up with negative 348.1 meters per second squared. And check this out, when this square will go to both, right? This becomes meters squared, second squared, but there's a meter down here, so this meter cancels, that meter cancels. You end up with the unit meters per second squared, which is great because we want an acceleration, and acceleration is expressed in meters per second squared. Notice how if you just keep the units, it kind of confirms whether or not you did it right. Unfortunately, this problem is weird, and this is not the answer they want. They want the answer in lousy G's, so we need to convert to G's. So our given in this case is negative 348.1 meters per second squared. We know that the acceleration of gravity is 9.8 meters per second squared. This is 1 g, so this whole thing cancels, right? This cancels. So it's just 348.1 divided by 9.8. I do a little bit of math. Let me punch that in. 348.1 divided by 9.8. And I get 35.520, blah, blah, blah. But this is in G's. But we're only given 2 sig figs here. Look, 2 sig figs, right? So we got to report 2 sig figs, meaning we're going to rewrite this. Oops, this is a negative, right? As negative 36 G's. That is our answer. Really long video. Thank you very much for watching. I really appreciate all the hard work you're putting in. Thank you for being my student. And I will see you guys later.